Oh, my word. Hello. It is Wednesday, and in today's edition of Kitchen Table Chemistry, we are going to do some reactions with alcohols. And I've given myself a whiteboard here to draw some things in with. So, alcohols as a group, we're going to look at two kinds of reactions: dehydration reactions and substitution reactions. These are by no means all the reactions that occur with alcohols, but these are two that we can take a look at and learn from. Both of these reactions are going to remove the hydroxyl or OH minus group from the alcohol. They're both going to take place in acidic conditions and acidic solutions specifically. So these are solution type reactions. And neither reaction is going to stop at a carbocation, as this is not stable. What does the man mean, carbocation? Well, if we think of carbon and it's bonded to, say, a hydrogen and a carbon chain down here and another hydrogen here. A carbocation would be this: carbon as a cation. And this is not stable. This is not stable. Think about how small carbon is, and that this is not stable. So don't ever stop at a carbocation. All right. Okay, dehydration reactions. Here's our alcohol, and it's taking place in an acidic solution. So I've just written down that it's taking place in here. So in reality, what we want to do is draw our two pentanols, 1, 2, 3, 4, 5, with the hydroxide group on the second one here. And it's going to take place in acidic conditions. So that just means that there's going to be acid around it. We don't want to write the acid in like it's doing anything else but just being present there. Okay, here's my full structure. And we're going to, as it says, dehydrate this. So one of the two products that we're going to get from this thing is, of course, going to be water. That water is going to form from these here and from this hydrogen here. And what we're going to get then is H2O as one of the products. The other product that we're now going to get is a double bond forming. So we're going to get an alkene, and the alkene now is going to be 1, 2, 3, 4, 5, same as it was, pentanol. And now the double bond will be formed here where the hydrogen was and where the hydroxyl group was. So it will fill in like that, and now what we're going to get is 2-pentene as the other product. Which way does the double bond form? You see it's kind of got choices here. There's fewer hydrogens on this carbon, so it's going to have a tendency to go to the carbon with fewer hydrogens. In reality, you'll actually get 1-pentene and 2-pentene as the product. So I will accept either one as correct, but in general, you want to make that pi bond, that double bond forming towards the carbon that has fewer hydrogens. Okay, next we have a substitution reaction. So I'll start off with butanol, 1, 2, 3, 4, and then our hydroxyl group here on the end. And nothing else is going to come into play here, so I'm not going to draw it. We are going to add the hydrobromic acid in this case because the hydrobromic acid is going to get used. So there's our reactants. So our products again here, we're going to be removing the hydroxyl group and combining it with this hydrogen to make a water, H2O. The other product now is going to be the butane molecule. I just did that. I just want to use a different color, that's all. Which is 1, 2, 3, 4, and now attached to the end is the bromine. So this is a what this is going to be called is bromo, because it's bromine, bromo, butane. There's no reason to say 1-bromobutane because it's on the first carbon. The only other thing you could have is if it was on the second carbon, then it would be 2-bromobutane. Very, very easy things to name here. These are alkanes with halogens attached to them. And it would the same reaction would occur as you see up here with chlorine and with iodine. Often you'll use iodine as well in that, but you get these as your products. Again, it is called a substitution reaction. It is a little bit like a dehydration reaction because water is produced, and you don't get a you don't get a carbocation. You get these as your products. All right, I gave you some practice in recognizing these reaction types with alcohols, and I hope it goes well for you. I will put out an answer key, and today's Wednesday, so I'll probably put an answer key out Thursday morning so you can check that out and see how you did. All right, we're getting done, guys. Only a few days left. I hope you are awesome on this lovely Wednesday. Take care.